let's take a look at another CSCS sorting and searching problem, room allocation. So what's going on? We have a hotel and there are N customers coming, and they each want a room. And we know what day they're going to arrive and depart. And we want to pack them into the minimum number of rooms possible. And 2 people can stay in the same room if the first one leaves before the second one arrives, right? So like 1, 2, and 4, 4 can stay in the same room because there's sort of time to get the room ready between 2 and 4. But 1, 2, and 2, 4 can't stay in the same room. They can't overlap. But like 1, 2, and 3, 4 could. And also, in addition to printing the number of rooms, we have to actually print out an assignment. So in this case, the first and the third person are going to stay in room 1, and the second person stay in room 2, and that would 2 rooms total. So the strategy here is actually pretty straightforward. Although actually getting anything in the assignment is kind of a pain. So the details are a little annoying. But basically, we're just going to process them in order of arrival time. So we need to sort them. And every time someone comes in, we assign them just any empty room. Preferably an empty room that we've already used. But if there isn't any, then we can conjure a new room up. And when they leave, we just say, okay, this room is empty now, it can get reused. And we just process sort of those events in order. So let's see how that looks. This is room allocation. Let's see, so this is N. So we're going to make a list of events sorted by time. So on day A, guest I plus 1 checks in. And on day B, guest I plus 1 checks out. So I'll write a negative to indicate that he's checking out. So we need a vector of pairs, I'll call E. And we want to sort it by time or by day. That's why we need to put the time first and the index second. By the way, the reason we need to write down the index is because we're sorting, we're going to scramble the order of them all up. But we need to output them in like an actual order. So we need to keep track of which index the room is on. Do a fancy code. So if they are checking in, positive number, we need to find an empty room. So we'll have a list of empty rooms. And we'll also keep track of the number of rooms that we assign people, which is our final answer. So if we have to conjure up a room, we'll keep track of the next ID, starting at 1. The first room is 1. Okay, so that's people checking in. How about people checking out? Oh, so it's very simple. We take the room that they were in, and then we mark it as empty. And we should handle ties correctly. So if there's a tie in the day, then you're not supposed to be allowed to use it. This is sorting low to high, so negative numbers will come first, if there's a tie in the first coordinate. And so you want them to check out like the next morning, basically. and then the people who arrive that evening can use the say morning and evening, just using a sort of a shorthand for negative number and positive number, right? We're saying that on a given day, because this is negative, all people checking out will come first for anyone checking in. So that's why p plus 1. And then we should print out the unit to use, which I will believe would be this. Okay, initially we use 0 rooms, but the next one is 1, so that makes sense. And then we should print out which room we're going to actually use. And we call these includes as seen vector vec. Pairs, the event queue, and so utility uses pairs, PLL is pair integers. And the reason that we want a deck is that we need to be able to push and pop quickly. I think we could actually just use a vector and do pop back and push back. Those are constant time, but whatever. It's fine too. We can use sort, actually some algorithm. And use variable d. That's true. This works. Okay, the fancy for loop is too fancy for me. There's the question of why we're zero is ambiguous otherwise. Okay, sure. I thought the difference between 0 and minus 0. Feels like this might have been an overly complicated way to do things, but whatever. To 0 is not valid. And events equal to e events qn. things off. Minus ID takes us back to I plus 1. Minus 1 takes us back to I. Okay. So what happened here? Person came in, we assigned them a new room with number 1. Other person came in. Room number 1 was still full, so we assigned them a new room with number 2. Person 1 checked out. Person 3 came in. We reused room number 1. Person 3 checked out, and person 2 checked out. That looks reasonable. Take out all of the standard error. That's the output that we want. Cool. So that worked. So what was going on here again? So we're reading in the input, the days that people come in, the days that they check out. We thought through the tie breaking. So we're keeping track of the list of events, which one we're going to process in order. So the events are someone checking in and checking out. So they check in with a positive ID. They check out with a negative ID. We're using ID, I plus 1 to handle 0. Otherwise, we need to be able to tell the difference between 0 checking in and checking out. Right? 0 and negative 0 are the same number. B plus 1, because the tie breaking. So because we're using negative to represent checking out, and they can't stay in the same room on the same day, we're saying that on the B plus 1th day, they check out, and they all check out before people check in. We could have also used B and then represented checking in with a negative number. And so then everyone would check in first before people checked out, so they couldn't use the room on the same day. So anyway, you just need to make sure that the tie breaking is right. That's how we're handling it. It's kind of a subtle point. So anyway, then we can sort the events by time, and with this tie breaking thing we just talked about, and just process them in order. So if someone is checking in, then we give them a, we reuse a room if there are empty rooms available that we've already used, right, which is what this empty thing is keeping track of. So if we do have some rooms to be used, then just grab one of them and use it. Otherwise, assign them a fresh new room and check how many rooms we've used, essentially. So assign that to them, and when they're checking out, just add their room to the list of rooms that are ready to be reused. And then at the end, put on how many rooms we used, and also which room everyone got, which we assigned them as they checked in. So sort of conceptually straightforward, but I guess the implementation, this is slightly tricky. I messed it up. That's the debugging. This is a way to do it. It may not be the cleanest way, but hopefully it all sort of makes sense. And these are nice, sort of comments explaining what's going on. So that's the problem.